We're going to try to find how to supply expressions involving trig functions. And what we have here are ones where they're written as algebraic expressions. All right, and we're trying to find the equivalent to this expression. Now, in this, what we have right here are cotangent or arctangent of x. Now, like we did in some previous ones where we had numbers in here, remember this is the angle, all right? And this right here is the ratio of the right triangle that will give us the angle to this arctangent, okay? So, to figure this one out, in our example number 1, we're going to do just like we did all the other ones. We're going to first start with our, all right, triangle. Now for here, because we are not given any values, we're going to assume that all this is in quadrant 1, all right? Arctangent has quadrant 1 or quadrant 2, so we're going to say everything's in quadrant 1. Now arctangent is opposite, all right? In this case, it's opposite over adjacent, so it's going to be x over 1. Well, we're trying to find cotangent. Well, cotangent is going to be the opposite, or is going to be the reciprocal of tangent, so that was just going to be, our answer was going to be 1 over x. And obviously, x cannot be, all right, x is be greater than 0, okay, greater than 0, because it has to be a positive if we have that right there, okay? And that would be our solution, all right, that's our solution. Now let's look at example number 2, something a little bit more difficult. We have arc sine is x minus 1, all right, x minus 1. And so what we do is we do the same thing, all right? Here, what angle, we're going to assume this is going to be in the first quadrant again, okay? And right here we have arc sine is opposite over hypotenuse. So this hypotenuse is going to be 1. So now we're saying secant. Secant is the reciprocal of cosine, all right, of the angle. And so reciprocal of the cosine, we know the ratio is going to be hypotenuse over adjacent to that angle. Well, we don't know the adjacent leg, A, so what we're going to do is we're going to find that by using the Pythagorean theorem. And so we have is a squared plus x minus 1, which is our b squared, and that's going to equal 1 squared. Solving for a, what we have is 1 minus the quantity x minus 1, that quantity squared, and that's going to equal a. We'll take the square root of that. All right, so we can get a by itself. We're just going to use a positive portion because this right here is going to be positive because we are saying it's in the first quadrant. And so we have the square root of 1 minus x minus 1 squared. All right, now let's figure out what secant is going to be. Well, secant is hypotenuse, which is 1, over adjacent, which we found out to be the square root of 1 minus the quantity x minus 1 squared. Bada bing, bada boom, that, my friends, is our solution. And there we have it. Well, let's go one more. All right, one more. I'm going to change colors here so you can see it. So example number 3, when we're solving this, well, we're trying to find cosine of arc sine. Well, once again, we're going to assume this is going to be the first quadrant. All right, arc sine is opposite over hypotenuse, which in our hypotenuse here is r. We're looking for cosine. Cosine, if you recall, cosine of whatever this angle is going to be adjacent over hypotenuse. Well, we have our hypotenuse, but we need to know the adjacent. So just like we did in the previous one, we're going to use the Pythagorean theorem that was figured this out. So we're going to have, I'll call this a again. All right, a squared plus the quantity x minus h squared is going to equal r squared. Well, what is a going to be? Well, it's going to be r squared minus the quantity x minus h squared. We'll take the square root to get a by itself. And so that's what we have there. That we have the square root of r squared minus the quantity x minus h squared. Let's find our adjacent hypotenuse. Well, it's going to be the square root of r squared minus the quantity of x minus h squared all over r. And that's how we do it. All right. We found our expressions. All right, right now the expression that is equivalent to the expression right here. We did that, and we can pat ourselves on the back. Well, let's do one more or two more, and kind of practice doing this mantra. So what we have right here is we want to find another ratio. Okay, we know we have arctangent of 9 over x. We have arctangent. We're looking for what is the ratio then that will give me. All right, that would be equivalent to arctangent of 9 over x. Well, the key thing is we're looking for what triangle will that be. Well, we're going to, once again, assume this is going to be in the first quadrant. Tangent is TOA, so be opposite, 9 over adjacent x. Looking for sine. Sine, if you recall, sine of the angle, all right, and this is the angle we're referring to of the triangle, is going to be opposite over hypotenuse. Well, what do we not have here? We do not have that hypotenuse. So we're going to solve that hypotenuse by using the Pythagorean theorem again. X squared plus 9 squared is going to equal our hypotenuse. I'll just call that AC, C squared. And so C is going to equal the square root of x squared plus 9 squared. Well, to figure this out, we take our opposite, which is 9, over hypotenuse, which you just found out, which is C. Okay, so C is our hypotenuse. And so we have the square root of x squared plus 9, all right, squared, which is 81. Oh, cool. All right, so that's how we found that one, and that would be the inside of here. Well, how do we find something like this? Well, this is a little more complicated. We have cosine of this. We're looking for sine. Once again, figure out our triangle right there. We know that the cosine is going to be adjacent over hypotenuse, which is right here, x squared minus 2x plus 10. I'm looking for sine. Oh, sorry, that's cosine. I apologize. So cosine 3 would not be there. It would be adjacent, right? Because cosine is adjacent over hypotenuse. Sine, as we know, whatever the angle of this is, and here's our angle, we'll just say, is opposite over hypotenuse. That is a ratio we want to plug in there. Okay, so we have to use this. I call this b. So 3 squared plus b squared is going to equal the square root of x squared minus 2x plus 10. All right, and we're going to take that quantity and square it. Okay, so what we have then is 9 plus b squared. We'll have x squared minus 2x plus 10. We'll get b by itself, b squared by itself, so let's subtract that. We have x squared minus 2x plus 1. Well, if you notice it right here, it just so happens this is a perfect square, so b is going to equal the square root of this. Well, this can be simplified into x minus 1, that quantity times x minus 1, which is x minus 1, that quantity squared. All right, so we take that x minus 1, that quantity squared, take the square root of it, solve for b, and we have x minus uno. So here's our x minus uno. And so what is our ratio that is equivalent to this, our cosine of this ratio right here? Well, we're going to take our opposite, x minus 1, over our hypotenuse, the square root of x squared minus 2x plus 10. And that, my friends, is the ratio that's put inside arc sine that will give us an equivalent expression of our cosine of 3 over the square root of x squared minus 2x plus 10. Okay, well, what we just did right here was we went around and simplified expressions involving inverse trig functions. All right, we found some different ratios. We simplified using some algebraic expressions like these right here, and also use arc sine to find equivalent expressions. All right, given the ratio by using triangles to find the other ratio in the problem. All right, well, I hope this helps you out. And yeah, good luck and God bless the rest of your problems.